The Great Rift Valley, a colossal fracture in the Earth's crust. It stretches over 6,000 kilometers, a jagged scar across the African continent. The Great Rift Valley is a land of superlatives. It boasts the lowest point in Africa, the Danakil Depression in Ethiopia. In stark contrast, the valley is also home to Mount Kilimanjaro. Millions of years ago, the African continent was a very different place. Deep within the Earth's mantle, convection currents were already at work, slowly pulling Pangaea apart. Around 20 million years ago, these relentless forces began to tear apart the African plate. To truly understand the Great Rift Valley, we must journey back in time. Imagine Earth as it was eons ago, long before the dinosaurs roamed. The continents, as we know them, didn't exist. As Pangaea continued to rift apart, a new chapter unfolded. Focus your attention on the African plate, a massive tectonic plate. Around 40 million years ago, the African plate experienced a dramatic shift. The stretching of the African plate unleashed volcanic activity. As the crust thinned, magma found an escape route. Volcanoes erupted along the length of the rift, shaping the landscape. As the Great Rift Valley deepened, it intersected with river systems. These rivers encountered a growing chasm, forming vast inland lakes. These lakes became a defining feature of the Great Rift Valley. The Great Rift Valley, a place of breathtaking beauty and raw power, it's a landscape constantly reshaped by the forces deep within the Earth. The Earth speaks in many voices. In the Great Rift Valley, volcanic eruptions are a dramatic pronouncement. These eruptions are a constant reminder of the immense heat and pressure beneath the Earth's surface. Life in the Great Rift Valley is a testament to resilience. Despite the challenges, people have thrived here for millennia. They have adapted to the rhythms of the Earth, learning to live in harmony with its unpredictable nature. The Great Rift Valley is a time traveler's paradise. Its layers of rock, like pages in a history book, chronicle millions of years of geological history. Fossils, those precious remnants of past life, are found embedded in these layers, offering tantalizing glimpses into lost worlds. These fossils tell a story of evolution, of adaptation, and of the incredible diversity of life that has called this valley home. The valley is perhaps best known for its human ancestor fossils. Discoveries like Lucy, a 3.2-million-year-old Australopithecus afarensis skeleton found in Ethiopia, have revolutionized our understanding of human evolution. These fossils suggest that the Great Rift Valley, with its diverse habitats and changing environments, played a crucial role in the evolution of our species. But the fossil record here extends far beyond hominids. The valley has yielded a treasure trove of fossils, from giant crocodiles and saber-toothed cats to early elephants and giraffes. These fossils paint a vivid picture of past ecosystems, showcasing the incredible diversity of life that has flourished here over millions of years. The Great Rift Valley is a giant time capsule, preserving snapshots of life on Earth across vast stretches of time. Each fossil discovery adds a new piece to the puzzle, helping us to understand the interconnectedness of life and the processes that have shaped our planet. The valley is a reminder that our planet's history is not a linear progression, but rather a complex tapestry woven from countless threads of geological change, biological evolution, and the enduring power of life itself. The Great Rift Valley is not an isolated incident. It's a dramatic manifestation of a much larger tectonic ballet playing out on a continental scale. The African plate is a dynamic entity, constantly moving and interacting with its neighbors. Imagine a slow-motion waltz, where the dancers are colossal tectonic plates. This is the dance of the giants, and the Great Rift Valley is just one step in this intricate choreography. Imagine a slow-motion divorce playing out on a geological timescale. This aptly describes the relationship between the African and Arabian plates. Millions of years ago, these two massive plates were joined together, their land masses forming a continuous expanse. However, the relentless forces of plate tectonics had other plans. As the Earth's mantle churned beneath them, a new rift began to form, slowly pulling the two plates apart. This separation, occurring over millions of years, marked the birth of the Red Sea. This separation was not a clean break. As the plates pulled apart, magma from the Earth's mantle welled up to fill the void, creating new crust along the rift. This process, known as seafloor spreading, continues today, slowly widening the Red Sea at a rate of about an inch per year. Imagine a giant zipper, slowly unzipping the Earth's crust, allowing molten rock to bubble up and solidify, creating new land as the old drifts apart. The Red Sea, a narrow strip of water separating Africa from the Arabian Peninsula, is a testament to this ongoing process. Its waters, once a confined inland sea, are now connected to the Indian Ocean, their chemistry and ecology forever altered by this tectonic divorce. The Red Sea, with its coral reefs, mangroves, and diverse marine life, is a testament to nature's ability to adapt and thrive, even in the face of dramatic geological change. The Arabian Peninsula, once firmly anchored to Africa, is now slowly drifting northeastward towards Asia. Its eventual collision with Eurasia, millions of years in the future, will have profound consequences for the region, likely closing the Persian Gulf and uplifting new mountain ranges. This slow-motion collision, already underway, is a reminder that the Earth's surface is in a constant state of flux, its features constantly evolving over geological time. The East African Rift System, a colossal fracture in the Earth's crust, offers a glimpse into the future of continents. This rift, stretching over 6,000 kilometers from Ethiopia in the north to Mozambique in the south, is where Africa is slowly but surely tearing itself apart. Imagine a giant zipper, slowly unzipping the continent, creating a new ocean basin in its wake. This is the process of continental rifting, and it's happening right before our eyes, albeit at a pace so slow that it's barely perceptible on a human timescale. The driving force behind this tectonic drama is the upwelling of heat from the Earth's mantle, the layer of molten rock beneath the crust. This heat, rising from the planet's core, creates convection currents in the mantle, dragging the overlying tectonic plates along for the ride. In East Africa, these currents are pulling the African plate apart, stretching and thinning the crust until it eventually fractures. These fractures, known as rift valleys, are the first visible signs of continental breakup. The East African Rift is not a single continuous fracture. Instead, it consists of a series of interconnected rift valleys, each at a different stage of development. Some, like the Afar Triangle in Ethiopia, are already below sea level, flooded by seawater to create nascent ocean basins. Others, like the Great Rift Valley itself, are still above sea level, their floors marked by volcanoes, lakes, and unique ecosystems. As the rifting process continues, these valleys will widen and deepen, eventually becoming flooded by seawater. Millions of years from now, the East African Rift System will have transformed into a new ocean, dividing the African continent in two. This new ocean, still unnamed, will have its own unique currents, temperatures, and marine life, further increasing the planet's biodiversity. The Great Rift Valley is a landscape shaped by millions of years of tectonic activity. Earthquakes, volcanic eruptions, and shifting tectonic plates have sculpted this region. Imagine a sculptor molding the Earth's surface with each tremor and eruption. The rocks tell a story of geological events stretching back millions of years. Towering escarpments and steep cliffs are testaments to immense forces at work. While the East African Rift System offers a glimpse into the future of continents breaking apart, the collision zone between the African and Eurasian plates provides a stark contrast, showcasing the dramatic consequences of continents colliding. This slow-motion collision, occurring over millions of years, has crumpled and uplifted the Earth's crust, creating some of the planet's most impressive mountain ranges. Imagine two colossal bulldozers, each representing a continent, pushing against each other with unimaginable force. This is the scale of the collision between Africa and Eurasia. The Earth's crust, unable to withstand this immense pressure, buckles, folds, and uplifts, creating towering mountain ranges. This is the process that gave rise to the Alps, the Caucasus Mountains, and the Zagros Mountains, all testaments to the power of continental collisions. This collision is not a static event, it's an ongoing process, with the African plate continuing to push northward into Eurasia at a rate of a few centimeters per year. This ongoing pressure means that these mountain ranges are still growing, albeit at a pace so slow that it's imperceptible on a human timescale. Each year, these mountains grow a tiny bit taller, their peaks reaching further towards the sky. This collision has had profound consequences for the region, not just in terms of its topography, but also its climate and ecology. The uplift of the Himalayas, for example, has significantly altered atmospheric circulation patterns, influencing monsoon systems and creating a rain shadow effect that has led to the formation of the arid Gobi Desert. Imagine a wall of rock, so high that it blocks rain clouds, creating a stark contrast in climate and vegetation on either side. Gaze into the crystal ball of geological time and witness the African continent in a state of dramatic transformation. The Great Rift Valley, already a colossal scar on the Earth's surface, is projected to widen and deepen over the next few million years. This is not a sudden cataclysmic event, but rather a slow, inexorable process, driven by the relentless forces of plate tectonics. Imagine a giant jigsaw puzzle slowly being pulled apart, each piece representing a segment of the African plate, their edges grinding and separating as they drift on the Earth's mantle. As the rift widens, the land between its eastern and western branches, a swathe of East Africa encompassing parts of Ethiopia, Somalia, Kenya, and Tanzania, will become increasingly isolated. This isolation will have profound consequences for the region's geology, climate, and ecology. Imagine a bridge slowly crumbling, its sections drifting further apart, isolating the landmass it once connected. The most dramatic prediction is the eventual separation of this landmass from the rest of Africa, forming a new, smaller continent. This new continent, sometimes referred to as East Africa or the Somali Plate, will be adrift in the Indian Ocean, its destiny shaped by the same tectonic forces that birthed it. Imagine a ship, cast adrift from its moorings, setting sail on an uncertain journey across a vast ocean. This separation will not happen overnight. It's a process that will unfold over millions of years, with each passing millennium witnessing further widening of the rift, more volcanic eruptions, and a gradual reshaping of the landscape. Imagine a sculptor working patiently over eons, slowly molding and shaping the Earth's surface, their every touch leaving an enduring mark on the planet's face. As the East African Rift System continues to widen, seawater will gradually inundate the deepening chasm. This will mark the birth of a new ocean basin, initially a narrow sea separating the newly formed continent from mainland Africa, but eventually growing into a vast expanse of water rivaling the Atlantic or Pacific in size. Imagine a bathtub slowly filling with water, the rising level eventually submerging the edges and creating a miniature sea. This new ocean, still unnamed, will have its own unique characteristics, shaped by its location, climate, and the geological processes that created it. Its waters, warmed by the tropical sun, will teem with marine life, creating new ecosystems and providing opportunities for the evolution of countless new species. Imagine a blank canvas, ready to be painted with the vibrant colors of life, As evolution takes its course in this newly formed environment, the coastal regions of the newly formed continent and the remaining African landmass will undergo dramatic transformations. Volcanic activity, already a defining feature of the Rift Valley, will intensify as magma rises to fill the gaps created by the separating plates. New volcanoes will emerge from the sea floor, creating chains of volcanic islands that will dot the ocean basin. Imagine a fireworks display, frozen in time, as molten rock erupts from the ocean depths, creating islands that rise from the waves like sentinels of the deep. The formation of this new ocean will have far-reaching consequences for global climate patterns, ocean currents, and the distribution of plant and animal life. It will be a catalyst for evolutionary change, driving the emergence of new species and the reshaping of existing ecosystems on both land and sea. Imagine a ripple effect, spreading outwards from this nascent ocean, its influence felt across the planet as life adapts to the changing world. The East African Rift System is a dynamic landscape. Isolated pockets of land will become islands, surrounded by newly formed lakes. These islands will become havens for biodiversity, fostering unique species. Lakes will evolve unique ecosystems, shaped by their chemistry and depth. Mountains will rise, isolating populations and creating new species. The Great Rift Valley is a dynamic stage for life's drama, shaped by ancient and evolving forces. The future of the Great Rift Valley is a human concern too. Millions call this region home, their lives intertwined with its land and resources. As the rift widens, communities face unprecedented challenges, requiring innovative solutions. Geological hazards pose significant risks to human settlements and infrastructure. Early warning systems and resilient infrastructure are crucial for safety. Imagine sensors monitoring tremors, providing timely warnings for safety. Extreme weather impacts agriculture, water resources, and human health. Sustainable practices and climate-resilient crops ensure food security. Imagine fields with drought-resistant crops and water harvesting techniques. Displacement due to hazards requires careful planning and resettlement. Preserving cultural heritage and traditional knowledge is paramount. Imagine a solar-powered community center, a hub for sharing knowledge. The future requires collaboration between scientists, policymakers, and communities. Understanding geological forces and working together ensures a thriving future. Imagine a future where the Great Rift Valley becomes a model for sustainable development, balancing nature and human ingenuity. The Great Rift Valley stands as a testament to the Earth's raw power. A colossal fracture in the planet's surface, a scar of creation stretching over thousands of kilometers. It's a place where the Earth's heartbeat is palpable, where the forces that have shaped our planet for billions of years are on full display. We've journeyed through vast stretches of time, witnessing the breakup of continents, the birth of oceans, and the fiery breath of volcanoes sculpting the land. Our exploration has revealed a landscape in perpetual motion, a place where change is the only constant. We've seen how the slow, relentless dance of tectonic plates has rifted the Earth's crust, creating a chasm that has become a cradle of evolution. Within its depths, unique ecosystems have flourished, shaped by the valley's unique geology and climate. The Great Rift Valley is a living laboratory of evolution, a place where life has adapted to thrive in a landscape forever in flux. But this story is far from over. The forces that created the Great Rift Valley are still at work, slowly reshaping the African continent, inch by geological inch. In millions of years, the rift will widen, a new ocean will be born, and the map of our planet will be redrawn. The Great Rift Valley, a symbol of Africa's ancient past, also holds the key to its distant future. As we've delved into the science, we've also encountered the human story interwoven with the landscape. We've seen the resilience of communities who call this valley home, their lives intertwined with the rhythms of the earth, adapting to its challenges and drawing sustenance from its bounty. The future of the Great Rift Valley is not just a geological concern, it's a human one, a story that will be written by the choices we make today. The Great Rift Valley stands as a testament to the Earth's raw power, a colossal fracture in the planet's surface, a scar of creation stretching over thousands of kilometers. It's a place where the Earth's heartbeat is palpable, where the forces that have shaped our planet for billions of years are on full display. Understanding the Great Rift Valley and its story is not just an academic pursuit, it's a call to action. As we've seen, this region is a microcosm of the challenges and opportunities facing our planet. Climate change, biodiversity loss, and the sustainable management of resources are issues that resonate far beyond the valley's towering escarpments. The lessons learned here, from studying the Earth's history, monitoring its present, and projecting its future, can inform our actions on a global scale. By understanding the intricate connections between geology, climate, and life, we can make more informed decisions about how we manage our planet's resources and mitigate the impacts of climate change. The Great Rift Valley, with its stark beauty and profound lessons, reminds us of our place within the grand scheme of Earth's history. It underscores the interconnectedness of all living things and the importance of respecting the delicate balance of nature. Let the story of the Great Rift Valley inspire us to become better stewards of our planet, to embrace scientific curiosity, and to work together to create a sustainable future for all.